Everybody there? Okay. I just sent back the quizzes, not quizzes, the hand-in assignments that you guys did for me that you had a week to do to kind of give me an indication of how this Unit 7 is going. It's one of the tougher units for sure. Included in what I gave you guys was a partial formula sheet with some terminology. These were all old exam questions. So I noticed that there's some people that are lacking, they're losing half marks for algebraic errors and notational errors, and pretty tough for me to explain when I'm just sending you back the mark you got on a question. So I'm going to go through each of the questions that I marked and talk a little bit about where I noticed some errors occurring. So hopefully you can do your corrections and understand where you might have lost some marks. As well as some of us are not sure at all how to do some of these questions, so I'm going to really go in depth with each of them to hopefully help fix some of the misunderstanding. Okay, the first question. So obviously if you got 1 out of 1 on this question, you don't need to watch the full extent of question 1. So go to the questions that you need to watch again. So here we have Gina has done this question and she stopped part way through. So the first thing we need to do is recognize that we're trying to find the answer for all real values of theta, and that's where people messed up. A lot of people stayed between 0 and 2 pi, like most questions, but this question said all values. So we need to include coterminal angles. We need to go infinite times around the circle. So we need a general solution here. Okay, so I'm just making a note. We need a general solution. So a lot of people lost part marks here. This is actually a 2 or 3 mark question. I'm not sure why I had 1 mark here, but so I'll go through it. So the first thing you need to find out what makes theta equal to 0 for this term. So most people were okay here. 3 sine theta equals -1. Sine theta is equal to -1/3. And you must use a calculator for that because that's not one of our nice unit circle values. So it's negative, so theta exists according to the cast rule in quadrants 3 and in quadrant 4 here. So to find the reference angle in the triangle, we take the sine inverse of a +1/3. The negative is just there to tell us what quadrant it's in. And on your graphing calculator, in radians, don't forget, you should have got 0.34 radians. So let's do that calculation now. Let's move that over. Whoa, I don't want to move that over. Let's move this over. I'll put it over here. So in quadrant 3, we know that in quadrant 3 it's pi plus the reference angle, so pi plus 0.34 radians should give us, rounded to the nearest tenth, 3.5 radians. And in quadrant 4, it's 2 pi subtract the reference angle, which gives us 5.9 radians. So those are the 2 answers if I had a question with a search area between 0 and 2 pi, but this question had all real values. So one answer is 3.5, but to get to all the answers at that same location, you have to add 2 pi to that. So therefore we say theta equals 3.5 radians plus 2 pi k times, where k is an integer. That will get all its coterminal angles. And also at 5.9 radians, we do the same. I just realized that the question said to the nearest 3 decimal places, so I'd lose a half mark for my answer, but I didn't dock you guys for rounding errors. So that was worth a half mark each for each of those solutions, okay? The solutions were worth half a mark each. Now also, you'd lose a half mark if you didn't say here, well, sine theta is equal to 5, and there's no solution for that because sine has to be between -1 and 1. You can't have an opposite bigger than the hypotenuse. So hopefully that fixes some of your understanding of what was needed to be done for number 1. Okay, number 2. Number 2, this question was out of 2 marks, and I wanted it to be done algebraically. A couple of you did it graphically and got full marks, but I should have said algebraically because there was no calculator for this one. So if you're doing it graphically, you use the calculator. So the first thing we have to do is isolate theta, and we do have a search area here of 0 to 2 pi. So 2 cos of 2 theta is equal to 1. Divide both sides by 2, and you get cos of 2 theta equals 1/2. Now, understand here that that b value of 2, the b value of 2, means a horizontal compression of 1/2. So understand that we're going to be doubling an angle and finding the cosine of that angle. We're compressing by 1/2. So what you need to do here, and I set this up in a previous video, you need to pick a letter and substitute it in for the b value times theta and solve this question under normal conditions. So this would be cosine of u equals 1/2. So solve that first. So we don't need a calculator for that. We know that cosine is 1/2 at what values on the unit circle? What values? Well, angle u has a cosine of 1/2 at pi over 3, and also at, what's the other one in the unit circle? 5 pi over 3 is where cosine's 1/2. Now understand that that's 2 theta. That's double some angle, gives us those measures. Well, to find theta, we're going to be dividing those angles by 2 eventually. So 2 times pi over 6 is pi over 3, and 2 times 5 pi over 6 is 5 pi over 3. So what you need to do, folks, is go around twice. So here's a clue. If this is 2, go around the circle that many times. So if that was a 3, go around the circle 3 times. A lot of people made this error, understandably so if you haven't watched a video on this. So you have to add one more coterminal angle to this. Go around again. 2 pi plus pi over 3. 2 pi is 6/3, so that'd be 7 pi over 3. And add another 2 pi to 5 pi over 3. 6/3 would make that 11 pi over 3. And some of you are saying, oh, that's over 2 pi. Well, yeah, it is, but theta must be between 0 and 2 pi. Because look what's happening next. We're going to divide both sides by 2 to get theta. So that would leave us 2 divided by 2, 1 theta equals, what's pi over 3 divided by 2? Pi over 6. 5 pi over 3 divided by 2 is 5 pi over 6. 7 pi over 6. And 11 pi over 6. Would you agree that those angles are all between 0 and 2 pi? Absolutely. So make note of that. That's a very popular exam-style question. Make that correction so you don't make it again going further. So that's number 2. Number 3, that question was done pretty well. For these identity questions, you want to have your formula sheet in front of you. So you guys have a pretty extensive formula sheet. I'm just going to grab these 2 rules here. Where's my copy? Here it is. I'm going to copy these formulas down when I do these questions. Right here. Those 3 right there. Okay. I want to copy those to the clipboard. Okay, now let's go back to the question. Hopefully this works. Paste those there. Paste those there. Try that again. Sorry for the delay here, folks. Let's try that again. Let's copy those formulas. Okay, let's go back to the question. Let's put those formulas. Oh, it's not working. I'm going to pause the video so I can do this properly. Okay, I'm back. All right, so important to have your formula sheet in front of you. Cos squared times 1 plus cotangent squared. A lot of different ways to do these questions, but this question here, since it's saying cos squared cotangent squared, should make us think of these Pythagorean identities. Okay, so there should be a quick way to simplify this. Cotangent squared plus 1. Well, cotangent squared plus 1 can be simplified, if we look at the bottom, I'm circling this, as cosecant squared theta. So I could write that as cosine squared theta times cosecant squared theta. So that's definitely simpler. If I look at the answers, they're all monomials. So there's got to be something that must cancel on what I have left. So one obvious substitution I could make is saying, well, cosecant is the reciprocal of sine. So that leaves us with cos squared times 1 over sine squared. And if I wanted to write that as one single trigonometric ratio, that would be cos squared over sine squared, which is cotangent squared theta. So that's why the answer was C. So that's one way to get to C. Number 4 is saying non-permissibles. Non-permissibles are values that make the entire denominator equal to 0. What makes cos of x plus 1 equal to 0 is a non-permissible because 1 divided by 0 is undefined. So I need to solve this little equation without a calculator, and I see that whatever makes cos of x negative 1 is a non-permissible. So at what angle is cos of x negative 1? You should have said pi. So the answer was C. Those questions were done pretty well. Some people made mistakes on number 4, but hopefully we fixed that. Number 5. Okay. Now here's where I'm going to slow down a little bit. When we do these identities, there's guaranteed one on the provincial exam that typically in a normal year you'd be writing. I'm going to put those identities here on the side. I might need them. And I'm going to say that for a lot of these questions, there's more than one way to do it. So I'm going to try and predict the simplest way. And I'm also going to make comments as to some of the errors I noticed while marking that occurred. So number 5. I noticed the left-hand side and right-hand side both have operations, but the right-hand side is definitely more complicated. I want to take the right-hand side and do something with it. So I'm just going to start by rewriting it. And I'm going to change cotangent right now into a form of cosine over sine. Okay, that's cotangent, but that's over sine still, right? So I grab a half a mark for that substitution. When we mark identities, it's a little different too because I can gain a half a mark by writing something, but I can also lose a half a mark with an error that might occur. So sometimes you might look and say, hey, I did something right, but if something else is wrong, that might negate your right. So that's confusing, but yeah, marking identities is different. So I've got something going on the right. I'm changing into forms of sine and cosine, which is making sense because the left-hand side has cosine in it. So you need to ask yourself, what's the right-hand side asking me to do? Well, it's asking me to divide right here. So do that. So I'm going to do that. I'm going to leave cosecant squared theta for a second. I'm just manipulating this part here. So to divide means to do exactly that. Remember, if you're dividing by sine theta, that's the same as dividing by sine theta over 1. which in previous grades we learned we need to multiply by that reciprocal. Show that work, people. If you don't show that, it's tough to mark, and you often might lose a half a step. For proofs, you need to show all steps. You cannot skip any. So I'm rewriting cosecant squared. Now I'm going to simplify what I have here. I have cos theta times 1 over sine squared theta. Now here comes one half mark error. I'm going to make it on purpose. I'm going to write this as sine theta squared. I'd say about 15 of you at some point in your identity might have written it like that. Now, it's not the sine theta squared. It's not the angle that's squared. It's sine that's squared theta, or you could write it as sine theta all squared. Those two versions are correct. This sine theta squared is incorrect. So watch out for that. So I'm going to change that to one of these two. I'll pick this one since it's more common. Sine squared of theta. So watch out for that, folks. So you might notice if you got 2.5 out of 3, that might have been your only error. Now, continuing on. The left-hand side is in terms of cosine. So on the right-hand side, why not make cosecant squared theta the same as 1 over sine squared theta? Now it'll have the same denominator as the fraction I've just created. And what do we do when we subtract fractions? We put them together, and in this case, the denominator is the same, so it's not much work here. You put the denominators together. So what we have is 1 minus cos theta over sine squared theta. Now I'm just going to rewrite my left-hand side since it's kind of blurry, 1 plus cos theta. Is there a way to make sine squared become cosine? Well, there is, and I'm going up to my formula sheet. Right here is our Pythagorean identity. Could I write that as sine squared theta equals 1 minus cos squared theta? Now that's going to prove efficient because now I've got sine squared theta as 1 minus cos squared theta. That's where I'm at. Now how do I get from here to the left-hand side, 1 plus cos theta? Isn't this suggesting that maybe a factor of 1 minus cos theta will need to cancel? And in the denominator, do you notice this is the difference of squares? So I rewrite my numerator. In the denominator, this is the difference of squares. 1 minus cos theta times 1 plus cos theta. Difference of squares, and because of that, I can now cancel this common factor because I'm multiplying and dividing. That leaves me with exactly what I'm looking for, 1 over 1 plus cos theta. Left-hand side is now equal to the right-hand side. Now, just a heads up here. I'm just going to make another comment about a common error I'm seeing. If you had something like 1 minus cos theta over cos theta somewhere in an expression somewhere, it's not correct to take that binomial and cancel off two factors like that. Remember, cos theta in the denominator is divided into both 1 and into cos theta. So you cannot just cancel it off with one of them. The correct statement would have been 1 over cos theta minus cos theta over cos theta, and that cancels just in that 1. So I noticed an error similar to that occurring quite frequently in some people's identities. Okay, so I'll mention that a little bit more as we go. So that was worth 3 marks. That should have been worth 4, actually. Next one, number 6. Some weird stuff going on here. I had a lot of people coming up with some version of tangent out of cosine squared. Now, our formulas, there's nothing that changes cos squared directly to tangent. So that's kind of puzzling. So I'm going to grab my formula sheet, and before you start doing this, try and see if there's something a little more predictable that could happen. I'm definitely going to work with the left-hand side, and on the left-hand side, I've got cos squared. Well, cos squared is a good thing because it's going to simplify quite easily because I got cos squared on top and cos squared on the bottom. I'm thinking that the question's telling me to divide by cos squared, so why not do exactly what the question's telling you to do? So it'd be 1 over cos squared plus 2 cos squared over cos squared. Simplifying is always good. So because of that, I'm left with 1 over cos squared theta plus cos squared over cos squared cancels plus 2. Now, what can I do next? Well, I know cos squared, 1 over cos squared, is the same as sec squared, secant squared. And doesn't secant turn into tangent? Did you see what I just did here? Look here. Put your goggles on. Look here. Mr. Penning's not a very good drawer. Okay, so that becomes secant squared theta plus 2. And secant turns easily into tangent with this identity. So wherever I see a secant, I can write it in as tan squared theta plus 1. And that needs to be increased by 2. Whoa, tan squared theta plus 3. Okay, so there is a nice way to do the question. And back to the common theme. Whatever the question's kind of telling you to do that before seeking out other options. Oh, and I should say left-hand side equals right-hand side. That's always the way you want to end it. Anything more to say about that one? I think that's pretty good, isn't it? Okay, next one. Last one says, explain the error that occurred in the following equation. Well, we're going to learn more about this sine 2 theta identity later, but let's accept what this student has done. Okay, I know this is actually something we haven't learned yet, but it is on our formula sheet. So we'll accept that first step. We'll learn more about that later. Here's the error in step number 3. 1, 2, 3. Dividing both sides by cos theta. I know it's an equation. You can do that. But by doing that, you're losing some answers. You always want to factor first. So after this step, notice what happens. 2 sine theta cos theta. Bring the cos theta over to the left-hand side. Make it minus cos theta. And always set your equations equal to 0. Because what that helps you do is identify the following factors. So what's common to both? Cos theta times 2 sine theta minus 1 is the correct factorization of that. And here's where we see some answers might be different. There are, I'm going to go down here where I got more room, 2 roots. Cos theta equal to 0 makes the left-hand side equal to 0. And also sine theta equal to a half makes the left-hand side equal to 0. Notice that student X here only found the one root. Because they divided before they factored, they lost a root. So the moral of the story is FF, factor first, always. Okay, so let's finish the question. So cos theta equals 0, well, that occurs at pi over 2 and also at 3 pi over 2 in one rotation. And sine theta equals a half, that is in quadrants 1 and 2. That's at pi over 6, and in quadrant 2 at 5 pi over 6. And they're wanting, again, theta exists as a real number, so this is the general solution. So you have to take each of these, each of them, don't get lazy on me, and add full rotations to them. Add 2 pi k, k times, add 2 pi k, k times for each of them. Pi over 6, 2 pi k, k exists as an integer, and 5 pi over 6, 5 pi over 6, plus 2 pi k, k exists as an integer. Okay, so there's your final answer, those 4 statements, because you have to include all the coterminal. Now keep in mind too, on a provincial exam, or one way to make your statement shorter is you could actually combine these 2 statements, right? Because how are pi over 2 and 3 pi over 2 linked? Well, they're pi away. They're pi away from each other, as I just demonstrated. So you could write that as pi over 2 plus not 2 pi k, but 1 pi k, k exists as an integer, which basically combines those 2 statements into one, if you were so inclined. Okay, so hopefully this helps you guys spend some time going over your quiz, making those corrections. And if you upload your corrections before 11 o'clock tonight, I'll go to Power School and add 1 or a half a point to your score. Okay, hope that was beneficial. And I hope you're watching it.